In this video, I'll be going over the basics of cosecant and secant graphs. First up is the cosecant graph. So remember, cosecant of x is the reciprocal of sine of x. And so because these two functions are reciprocals of each other, their graphs are quite closely related. So what we can see is we have the sine graph. We have the sine graph here. And that's just the normal sine wave, and it's in gray. And then what we see is that the cosecant portion of the graph is these u's and these upside down u's. And they're based upon where the sine graph has its maximum values and minimum values. So if we can correctly graph a sine function, the cosecant graph is just a couple more steps. So the first step is identifying the maximums and the minimums and then drawing those u's and upside down u's. And then the other thing to notice is we have these asymptotes here. So here and here are asymptote lines, vertical asymptotes. And there's one here, and then here and here. So in this image, there's 5 asymptotes, but in fact, this graph goes from negative infinity to positive infinity, so there are an infinite number of asymptotes, and it looks like they occur every pi units. Every time we're 1 pi further to the right, we get another vertical asymptote. And hopefully you can make sense of this, or maybe what I should say is these asymptotes are coming from places on the unit circle where cosecant is undefined. So if I look at the unit circle, and since cosecant is 1 over sine, this will be undefined whenever sine is equal to 0. And sine is equal to 0 at here and here, right? Those the coordinates at that first point is 1, 0, and that is at 0 radians, or at 2 pi radians, or at 4 pi radians if we keep going around in circles. So sine of any of these values is equal to 0. So the cosecant value is 1 over 0, which makes that undefined. Similarly, at pi over here, I get negative 1, 0. Sine at pi is equal to 0. So cosecant of, that's not how we write it, cosecant of pi is equal to 1 over 0, which is undefined. And that's why we have the asymptote at that value pi, which is this one right here. Okay, so anytime the sine value is 0, that also tells us that the cosecant value is undefined, and that's where we have vertical asymptotes. All right, let's look at a similar image for cosine and secant. Okay, so similar idea. We have the cosine graph in the middle, bouncing up and down, and then the secant graph appears wherever the cosine graph has a positive value, or I'm sorry, a maximum value and a minimum value. Okay, one thing I didn't mention previously is that the period length for these secant and cosecant graphs is 2 pi, just like the period length for the regular sine and cosine parent functions. All right, so just like we saw before, to graph secant, we first graph a cosine function, and then the secant portion appears wherever we have a maximum value and a minimum value on the cosine graph. And then similarly, we also have those vertical asymptotes, and these are going to appear now whenever cosine is 0. So at this point and this point, so that's pi over 2, and the coordinates there are 1 or 0, 1. Cosine of pi over 2 is equal to 0. Secant is just the reciprocal of that, so secant of pi over 2 is equal to 1 over 0, which is undefined. And that's going to happen also down here at 3 pi over 2 and every other coterminal angle for those two positions. So this right here, pi over 2, gives us a vertical asymptote, and also at 3 pi over 2. Yeah, that's that's kind of a quick overview of the secant and the cosecant graphs.